Uh, Good morning, ladies and gentlemen. Today we are going to start our next lecture. Uh, the lecture is dedicated to programming language that we call FBD, functional block diagrams. Uh, so, is a graphical programming language. It works with a sequence of chains, each of which contains a logical or arithmetic expression, a functional block call, a jump, or a return instruction. So, a program written in this language for a PLC consists of a list of circuits that are executed by one from top to bottom. Allows you to use powerful algorithms by simply calling functions and function blocks. So, next, there is also the possibility of assigning separate chains of labels. In this case, will be available for the use of the instructions to the label in the order to change the sequence of execution chains and to create the conditions and cycles. So this is the general view of implementation of some logic in this language. So what about syntax of this language? A separate block carries a specific function, for example, logical AND, NOT, contest, etc. And a single block can have multiple outputs and inputs. Initially, the values of variables are set by constants or special inputs, and their outputs are associated further with other program variables or with the outputs of the PLC. In FBD language programming process, both standard blocks from libraries are used as well as blocks written in FBD. A block is a program element, a kind of subroutine, function block or function, for example, logical NOT, OR, AND, timer, counter, trigger, mathematical operation, analog signal processing, and so on. From these blocks, expressions that form chains are graphically composed. The next block is attached to the output of one block, then another block, and so chains are formed. So the main aim is we need to form a chain in this program language. Along the chain, the order of execution of blocks corresponds to the order of their connection, and the result of the chain execution is either fed to the output of the PLC or written to some internal variable. So, what about FBD elements? So, main element we call element. You can use this command to insert operators, functions, function blocks, and programs into our chain or scheme. Input adds an input operator or variable. Some operators can have a variable number of inputs. For example, operation add can have two or more inputs. So next, output adds a new assignment to an existing one. This allows you to pass a single value to multiple variables at once. Assignment. We use this operation by this command. This command inserts an assignment statement into the chain or circuit. So inversion. Yes. You can use this command to invert inputs, outputs, and transition or return instructions. The negative symbol is a small circle at the junction. So next element is set reset operator. You can use this command to define set or reset outputs. Set output is indicated by the letter S and reset output by the letter R. Return, operation return. This command inserts the return instruction. Jump. This command inserts a jump instruction. Depending on the cursor position, the jump instruction will be inserted right before the selected input, output, or at the end of the diagram. Label. Each chain can have a label, but it's not present by default. You can put a label if you click on the first line of the chain right after the chain number. So its implementation in CoDesys. Yes, it's common view of the program written in FBD language in CoDesys programming complex. So as we see, we have some chains, and in each chain we have a function block which implements some operators or operations. Okay, let's comparison of programs in FBD and CFC languages. So our task is as next we need to write a logical device program for the PLC and the CFC and FBD languages in accordance with the truth table, and we need to compare the results. So this is our truth table. So this is the equation corresponds to the truth table, and we need to write some programs in CFC and FBD languages and compare the results of this program. So implementation in CFC language of that equation. So implementation will be like in the picture as we see, and the next picture we can see the implementation in FBD language. So what can we say about implementation in FBD language? Each operation of our equation is made in separate chain. First we see the logical operations and are performed in this chain and this chain. So after that the logical OR operation is performed as we see in this OR block. After that we have inversion operation of this result. So in this lecture we talked about FBD language. As we see, it's very close to CFC programming language, but we need to notice some features of this language by programming in this language. So thank you very much for listening and good luck.